And if it is not one channel image, what we do is we average it out. Right? I take the next layer here, and then I simply get another channel like the same in the other part, and then I can start doing the average between the three channels. Okay, this is the simplest way of doing a channel-wise average. And once I average that, what I'm going to get a new image, which is typically a 3x3 again, the same size. Like this, right? Okay. So now Sobel filtering, what it does is it does directional filtering. So what it does only in the two directions, X and Y, right? So which means if I have this pixel out, so what am I supposed to do? I'm supposed to find the transition between the two pixels, right? Make sense? Understandable? Okay. So here is the black pixel. So what I'm going to do is when I'm going to run the filter in the X direction this way, then I'm going to capture the transitions that is happening between this pixel and this pixel, right? And then there is again a transition from 0 to 1, which is here, low to high, right? So which means it's typically giving me a response of this way. Actually, it should be the other way. Let's say 1 to 0, and then 0, and then 1, and then 0. Right? So it is 1, it is 0. So now you see that I can capture the directional variance in one side, right? Now, if I do the same the other way, on this side, my response would be almost 0 because there is really nothing changing across this pixel, across this pixel, across this pixel. All the three pixels are the same. Okay, so Sobel filtering is typically used to capture the directional changes, both in X direction and the Y direction. Okay, and then what is Gaussian blurring? So let's just, if I simply take an image like this, and then I would have a filter. Let's take a simple image like this. So if I have an image like this, when I do a Gaussian blurring, it blurs the areas, right? So why do we blur the areas in image processing typically? Because it's something that we also do in human vision. So we go from sharper details to the looser details, right? So we simulate that one using a filter called a Gaussian filter. And the Gaussian filter has three components, which is this. So here, if you see, there is a different size of the kernels, right? How much I need to blur. So I can start from anything from 1 cross 1, which means that it's going to filter every single pixel, which is not required. So what I'm going to do is that I'm going to start from 3 by 3, 5 by 5, 7 by 7, 9 by 9. And as I proceed, I can see that the image changes. And if you run the code right now, you'll be able to see this image. Now try to take a closer look at the image and then try to see how we are missing the details from the first image all the way to the last image. If you'd be able to see it also on your laptop, so you can see that the collar area, if you see here, in the neck area, also in the lip area, it becomes slightly blurry. Are you able to see that?
Yes.
Verify that one? Okay, good. Now you can do the same thing for the Sobel filtering. And now in the Sobel filtering, you see slightly different images. You see that the images are captured and they are activated only at the areas where there is edge transitions. Make sense? Okay. Now you can assume that we can extract the features from any face recognition system or any biometric system using such approaches. That makes sense? Yeah? Okay. So once you have this one, now you can start thinking about the combination of that. Instead of just using this, this is on the 8-bit Sobel images. And then if you do the same on the grayscale images, So now you see that the information is quite white and black, which only tells that where there is highest response and then where there is no response. Okay. Now, most of these things that we're discussing here is to just get you up to date with image processing. And now, if you look at this one, the original image and the response map from the Sobel and the response map from the other one, you see that these are the features that I could use for authentication in a very primitive system, right? Now, these systems are not going to give you any accuracy better than, I don't know, 10%, 12%, but you can still use it. So that is the idea here, right? Okay. And then now comes something more interesting here, right? So here you can see I am localizing the features which are more relevant. For instance, here I can see the areas files. Okay. And all I'm doing here is that I'm just playing with the filters so that I get the response map. And these response maps can be used further down. Okay. Again, remember all these things are not practically used anymore. So these things are all very obsolete. Then there is that is for the first part, and for the second one, if we can go back to so then there is this other one which is called as fingerprint visualization. Oh yeah, okay, then you're going to go to the second practical now, or do you need some time to go through the first one? You want to run it through and then 5 minutes. Yes. 5 minutes, okay. Just run it through and then tell me if you're not able to follow what is happening there. We can, you know.
इसको मान सीधा करना है सब यहाँ पे, ठीक है। अभी तो चलेगा उससे। अब एक इस बना अच्छा पहले वाला so that's so much. Okay, मेरे सब सही ये डीली क्लास must be okay. So we can continue with the biometric system application based fingerprint, at least to show how it works. One master screen. Speaking how it was showing at No, it's okay. तो ये कमांड है करना फिर मैं तो नंबर दे देंगे